All right. So let's look into how does the architecture looks like. So there are two components, master, and then we have the slaves. Master is the name node which actually stores the metadata and to support, because sometimes what happens, if I have only one master, then the chances, if let's the master is down or it is failed, right? So I need to have some sort of backup for this master as well, right? So because if the master fails and I don't have any backup of it, it means I mean, if master fails and if I don't have a backup, it means I cannot do anything with the cluster. So all my data which is present over here is kind of a garbage because I don't know where what is present, right? So it's very important that we need to have a backup. So the node which takes the backup of the master is known as a secondary name node, right? So these two are the master components, name node and secondary name node. And then the slaves are the regular data nodes which will actually store the data blocks. Okay. Now what exactly we have in the name node and the secondary name node? There are two very important files which are known as fs image and the edit logs. So these are the two important files what contains the actual metadata. So we are saying that name node stores the metadata, name node will have the entire structure of the file system, but where exactly name node stores all of this information, right? So there is a file, it's kind of a binary tree kind of a storage which is present, and this is called this is known as file system image. Okay, this image file name node, whenever we start the name node, the first thing it looks out for this fs image file, and whenever it gets started, it will be putting up all the content of this fs image file into its RAM, right? And then it will start serving, because name node will store the metadata in its RAM, because it needs a very fast response, right? If there are 100 clients looking out for the data, so name node must be able to serve all of them, right? So that's why it stores the entire fs image into its RAM. Now once we have the entire metadata stored in the RAM, the next thing which is the modifications, right? So let's say 10 clients, they are adding up new files, 5 of them are deleting some files. So whatever changes that is happening in the file system, all that will be recorded in this edit log file. So any entry, let's say you created a new file, right? So an entry will go into this edit log file. So any changes which is happening in the file system, all that transactions will be recorded in this edit logs. This is kind of a persistent image of the file. So don't you think that we have to merge these two? So let's take one example. Let's take a small example. I have a HDFS, right? So HDFS is having 10 files. Okay. So FS image, what does it contain? It will contain all information of 10 files. Like all information like blocks, replicas, everything, right? Where exactly those are present. Okay. Now one of the client came and he added the 11th file in the HDFS somewhere. Let's say he put a file in /user something, let's say /user and then bdhs and then 11th file.txt. Okay, so the moment he puts up this file, this entry will go into the edits log. So this entry will go into the edits log. Okay, and then after some time somebody came and somebody deleted the file, let's say one of the client, and then the 9th file got deleted. Okay, so this entry, like removal entry, will also go into the edits log. So all of these logs are going into the edits file. But what is my fs image contain? It contains 10 entries, right? Information of the file. So unless and until I merge the changes back to this FS image, this FS image will not be updated, right? So this has to be always kept updated, this FS image file, and maybe periodically, right? So we need to always keep this information updated. And why we need to keep it updated? Because whenever name node will start, if let's say there is a reboot or whatever, usually we don't power off name node, right? But even if let's say somebody is rebooted the name node, so it will always pick up this file and will load this entire data in the RAM. Okay, so this has to be always updated, and that update will come through the edit log. So we need to have a process which is continuously merging these changes into the FS image file. So can you tell me who can do this work? Who is responsible for ensuring like all the changes are getting merged in the FS image file? Who can do this?
Is it secondary name node?
Yeah, right, very good. So okay, sorry. All right, so correct. So that's the responsibility of the secondary name node. Okay, same secondary name node ensures like all the changes in the file system which is coming in the edit log, they are getting merged back to the FS image file, and we always have the correct up-to-date information in that file, right? So that's the purpose for secondary name node. Let me show you some diagram. Okay, so right, so this process of merging these two files is known as a checkpointing. Okay, and it's one of the important interview questions. So sometimes people ask what is checkpointing, who does it, who ensures all the changes are merged, and all of that, right? So what happens is we have a primary name node and we have a secondary name node. Both are two different servers, and primary name node will have FS image and the edits, right? The edit will contain all the changes which has happened. Now what secondary name node will do, it's going to pull this two file into its name into its own server, and then it's going to merge both of this and create a new FS image file and then transfer it back, right? And this is kind of it's kind of a periodic process which runs after a certain interval, and this cycle always continues, right? So this process is known as a checkpointing process, and while doing so it will also keep a copy of the updated FS image into its server. So if let's say due to some reason this name node crashed or it failed, we always have a backup present in the secondary name node. Okay, so both the purpose, like first purpose is merge both this, create a new version of the FS image file, and to maintain the backup into its own server, so in case of failure we can always look back and get it from the secondary name node, right? So that's the purpose of having a secondary name node.
Dheeraj, I have two questions on this.
Hmm.
Are you able to hear me?
Yeah.
Okay. So one thing is, if you don't have a secondary name node, so how primary name node will handle this operation? Number one.
Mm-hmm.
And number two questions. In case secondary node, I mean secondary node is active or is active passive replication? Okay. I mean, in case secondary node fails, what will be the reactions?
Very good. So in case if secondary name node fails, right, so then we have the problem and this process cannot continue, right? So it means like we will not have a backup present somewhere else. Okay, And
Okay.
you second you said about active or active passive, right? So it's always active, both are active. Now, what we need to understand is this checkpointing process is it's coming through the older version of the Hadoop, say Hadoop 1, right? It was very crucial in that. In the latest developments of the name node that we are going to learn now, this process is not that important because there is another way to deal with this process. So as you correctly said, like if secondary name node is down, it means, and nobody is doing that, it means we have a risk, right? So risk of losing the changes and all that, right? So all of these what we are learning, it was we had all those issues, right? So because of that only a newer version which is Hadoop 2 has come, and we are going to read like how exactly it handle all of that. So this active and active passive will come into play in the newer version. In this, there is no concept of active and active passive. These are two different server acting differently.
Okay. Okay. So you want to say one thing, 1.0 versions, it's mandatory to have a two primary node, sorry, two name node.
Not one name node and one secondary name node is mandatory.
Yeah. Okay. It's better or it is mandatory?
No, it's better. It's not mandatory. Without that also it will work, but you might lose the data.
So you meant to say if we have only one primary node, that means the same operation will happen within the primary node itself,
No,
the
no.
merging as well as.
If you don't have a secondary name node, then this operation will not happen.
Okay. So that means the FS image will contain the very basic initial stage at the time of starting, whatever is there, it will be available. The entire operation will be available, the edit logs.
Yes.
So there's no merging going to happen. Oh, so
Yep.
that's a big risk, right? Okay.
Yeah.
Fine. Yeah.
Yeah, that's kind of the risk.
Okay. Yeah. Thanks.
Okay. So all those issues were there in Hadoop 1, right? So that's what we are going to see now, like what were, and as you correctly said, right? So name node was a single point of failure, right? So you correctly pointed out like it was a big risk, and that risk was because if name node fails, it means everything is gone, right? You cannot do anything. So single point of failure, any solution, any architecture, any design which has a single point of the failure has a critical risk, and usually companies they don't prefer this type of solution in their for their production environments, right? So this was one of the biggest limitation of Hadoop 1, which is Hadoop 1.1.x versions. Okay. And what the second so what has been made available in the current version is a high availability of the name node. So instead of running one name node in the latest version, we have the concept of high availability, which is active and passive that you just said, right? So active passive concept came with the current version, which is the Hadoop 2. Okay. Second challenge that we had with the prior version was if let's say uh, due to some, let's say there is some issue and because of you have to restart the name node, right? So if there is any downtime for the name node, it means you cannot do anything, right? So that means like your entire cluster is down, which means you cannot read any data, you cannot write any data, you cannot do anything, right? And second thing is, and third point was like any plant maintenance would result in a window of the cluster downtime. So if even if you have to do any maintenance, let's say any upgrade or you have to put some patch or any such type of thing, would bring down the cluster. So all of these were the challenges in Hadoop 1. And to overcome all of these things, there is a concept of high availability and active passive configuration, right? So once we have this active passive configuration, high availability, these two features, so it means there is no downtime of the cluster now. Any upgrades, any patches, any maintenance window don't need the cluster shutdown. Okay. And it gives a 24 by 7 always running cluster, right? So there's the current version of Hadoop that we are going